Welcome back, Geometry Scholars. Today's lesson is 3.1, Sequences of Transformations, and 3.2, Proving Figures are Congruent Using Rigid Motions. Today's essential question is, how do transformations help identify and prove congruent or similar figures? So we're going to be looking for ways that we can use these different transformations to prove that two images are indeed the same or similar. And today's lesson objective is that the student will be able to transform images in a sequence on a coordinate plane. You'll notice on the left-hand side of your notes that there are no questions. This question area is where you as students should be writing questions that either A, the material answers, or B, perhaps you would like more information about. Moving right on to our notes. Transformations can be applied one after the other in a sequence where you use the image of the first transformation as the pre-image for the next transformation. Sometimes when two or more transformations are combined, the result may be the same as a single transformation. Transformations can be used to determine if two figures are indeed the same. Two figures are congruent, which means the same or equal, if and only if one can be obtained from the other by a sequence of rigid motions. For example, reflections, translations, and/or rotations. Example 1, we're going to draw the image of triangle ABC after the given combination of transformations. So letter A is we are going to reflect over line L, and then we are going to translate along the vector. Up until this point, we have been reflecting across the X or Y axis, which is definitely easy, and for a lot of you, very simple, something you could do very quickly. But now we're going to be talking a little bit more about reflecting over a line that is not the X or Y axis. So what we need is we need to first see, I'm going to start with point A, because point A is already on the line of reflection, and I'm going to find the slope to see when, what the slope would be in order to land back on the line of reflection. So I'm here on point A, and slope is rise over 1, so if I rise up 1 and I go over 2, here's another point on the line of reflection. So my original slope is 1 over 2. Now last lesson we talked about the slope of perpendicular lines. And the slope of perpendicular lines are opposite reciprocal or negative reciprocal. Either of those words are correct. So what is the opposite reciprocal of 1/2? Hopefully you said it was -2 over 1. And if you did, you would indeed be correct. So opposite reciprocal, not only do we flip it upside down, but we change the sign. So this is a little tricky because I'm reflecting up, and we know that since the slope is indeed negative, we should be going down. So what I need to do is I need to find the point above the line of reflection that will take me to the same point on the line of reflection as where point B lands. And let me explain this a little bit more. So B, as you can see, the line from B to the line of reflection is right here. And so if I go down 2 and over 1, I have point B. So I need to find the point on this above the line of reflection that when I go down 2 and over 1, I'm going to end right here as well. So I can see, like, if I go here, down 2 over 1, I'm not on the line of reflection. Or down 2 over 1, I'm not on the line of reflection. But you guys are definitely smart enough. You know, by just kind of doing the opposite, if I'm right here, and I go down 2 and over 1, I would land indeed right there as well. So this is our point B prime. So to clarify this, I'm just going to pick this spot right here on the line of reflection. I picked this random point, and I said, okay, B is down 2 and over 1 from the line of reflection. So I had to find the point above the line of reflection that I could also go down to and over 1 and land on the same point. And that was my B prime. So over here cannot be B prime. Actually, let me say, like over here, right here cannot be B prime, because even though I can go down to and over 1 and land on the line of reflection, it's not the same point it's not the same distance from B as this point is. So this point in green right here that I have put between B and B prime, it's 2 down and 1 away from B, and B prime is 2 down, it's 2 down and 1 away from B prime. Okay, so it sounds very complicated, but I know a lot of you were able to look at the image and say, oh, I know exactly where B prime goes. Okay, so don't let the actual terms that I'm teaching you confuse you. So there is B prime. And so now we need C prime. Okay, now remember, I'm working with the slope of -2/1. And so I need to find the point. So here's C, and I need to find the point on the line of reflection that I can go down to and over 1 and land on C. So I can tell by looking at it, this is my point on the line of reflection, because I can go down 2 and over 1 and land right there. Okay, so down 2, over 1, there's C. So now I need the point above the line of reflection that if I go down 2 and over 1, I land on that same point of reflection. And again, that same point on the line of reflection. So right here is my C prime, because if I go down 2 and over 1, I land on that same point as C did. Okay? So there is my C prime point. And where do you think A prime goes? Hopefully a lot of you said it goes right on the line of reflection, and if you did, you are correct. And so that is also A prime. So then simply connect your points. Obviously, I just got a little off. And there is your reflection. Excuse the fact that my line's not straight. As we've talked about before, writing on the smartboard isn't the easiest. There we go. That's a little straighter. Now at this point, we have reflected it over a line L. And remember, the first thing we did was we started at point A and we found the slope to when the next time we would be able to be on the line. And then we used that slope and we took the opposite reciprocal of it and made it a -2/1. So the opposite of 1/2 is -2/1. And we use that slope to find B prime and C prime. And we know that A and A prime happen to be on the same point. So now what we have to do is translate it along the vector. And this is where you guys won't have any issues because we've been doing vectors. So looking at the vector, the slope of the vector is right here. So we know that we can write it a few different ways. The rise is 1 over the run of 1, 2, 3, over the run of 4. I don't know why I wrote 1/2. I don't know if I'm thinking fractions of 1/2 for some reason. So the rise of 1 over the run of 4, or in component form, we'd be adding 4 and adding 1. Okay. So I have point B, and I'm going to go over to the right 4, 1, 2, 3, and 4, and I'm going to so that would be B double prime, and then C, I'm going to go over to the right. I'm sorry, I never went up. My apologies. And this is why in class you guys would be saying, Mrs. Locke, you skipped a step. So B, I go over to the right 4. 1, 2, 3, 4, and then up 1. So here is B double prime. And then C over to the right 4, 1, 2, 3, 4, and up 1. And here's C double prime. And A, 1, 2, 3, 4, and up 1. And here is A double prime. Last step, connect your points. And there you have your line that's been translated along the vector. Okay, I know it's a lot of steps. They're easy though if you stick with them. Let's look down at letter B. In class today, I told you that we would be doing some rotations or reflections around something other than the origin. And here's an example. We'll be doing a 180-degree rotation around point P, then translating it along the vector, then reflecting it across line L. So 3 different things we'll be doing right here. And I hope that you are ready to learn and to pay attention. So the first thing we have to do, which is the hardest one, is the 180-degree rotation around point P. And as you can see, there are no coordinates. Normally we know that 180-degree rotation, we keep the coordinates in the same spot, however we change the signs. Well, there are no signs. You can't even say, you don't even know if this is a negative, this line is on the negative y-axis or positive y-axis. We have no idea. So here's how we will take triangle ABC and rotate it around point P. Now we know from our geometry knowledge that we can draw a line, a straight line, between 2 points. So, for example, A to point P is a straight line, and C to point P is a straight line, and B to point P is a straight line. So we're going to use that information and use the distance of those points to help us find the 180-degree rotation. And normally I don't necessarily use distance for rotations, but because it's going to be a 180-degree rotation and I'm going to have to end up with a continuation of the same line, it will work this time. So, for example, I'm going to start with point B. So starting at point P, I see that my slope is up 3 over 1. So if I went 1, 2, 3, and over 1, my slope is up 3 over 1 to land me on point P. So I'm going to do the same thing, go up 3 over 1, and here is B prime. And it has the same slope, and if I were to draw a line, I can draw a straight line through point B, through point P, and through B prime. Okay, so it has to be a straight line. I can't say that point B prime is all the way over here because B to P to B prime, would not be a straight line. So I use the slope from B to P and then continue that same slope to B prime, so that way it would continue to be a straight line. Okay, so now I have B prime drawn. And then I'm going to do the same thing from A to A prime. From A to P and then on to P prime. So I can see that from A to P, the slope is 2 over 1. So I'm going to find a point. I'm going to find the spot where A prime should be. That's going to be 2 over 1 away from P. So I can see just again by looking at it, this point is 2 over 1 away from P. So there's my A prime. And I know, guys, a lot of you can look at this and just see where the points are going. I'm trying to show you how to find them, though, if you were to ever get stuck. Think about the distance, think about the slope. These are just common words that should be in our minds when we are working on problems like this. Okay? And then C is 1 to the left of P, so C prime is going to be 1 to the right of P. I accidentally erased my points. There we go. And so here are our points. And here is our 180-degree rotation. That should be a nice straight line. Okay, so there's my 180-degree rotation. Again, this was the hardest part, but really, it's actually not very hard just knowing you are using the slope. This one was definitely tricky, and for those of you that heard my breaking my phone story, this is the problem that made me break my phone, right here. Then we are translating it along the vector. And again, I need to look at the slope of the vector. The vector in component form is 1, 2, 3, 4, 5, comma 1. Or if you're writing in slope form, it's up 1 over 5. Okay, so translating along the vector, I'm going to use green for this. We go 5 over, 1, 2, 3, 4, 5, and up 1. So here is C double prime. And then A is 1, 2, 3, 4, 5 over, and 1 up. Here is A double prime. And B, 1, 2, 3, 4, 5. and up 1, B double prime. And now I have my translation. Okay. Lastly, we are going to reflect it across line L. And this reflection is super nice because it's a nice horizontal line. So we can do the counting, as a lot of you like to say. Can we just count? And yes, we can. So C prime is 1 above the line of reflection. So C triple prime is 1 below. B prime is 1, 2, 3, 4 above the line of reflection. So B triple prime, 1, 2, 3, 4, 4 below the line of reflection, and A double prime is 3 above. So A triple prime will be 3 below. And we've reflected it. And there we go. I've reflected the shape. And again, I know these shapes aren't perfect, but you guys get the idea. So again, the vector was 5 over 1, or if you want 5 comma 1, I'm sorry. Or if you think about it in slope, the slope was 1 over 5. Okay, whatever way kind of works for you. You got to find what works best for you. Okay, moving on. We're going to be drawing the images of the figure in the plane after the given combination of transformations. So it doesn't say what the transformations are, but obviously this is our starting point. And what kind of transformation is this? Hopefully you said it was a translation. You guys should be pretty comfortable with those now, just adding and subtracting. And then what about this next one? It's a dilation. And the last one, it's a rotation. So again, we're going to be performing 3 transformations in the plane after we find the points. So first of all, we have A, B, and C. So A is 2, 2. We need to apply the transformation. So I want you to go ahead and just fill in just the A prime, B prime, and C prime, just the transformation points. Hopefully your screen looks like mine. A prime is 1, 1, B prime is 1, 4, C prime is 2, 1, because 2 minus 1 is 1, 2 minus 1 is 1, okay? And so on. And so now I'm going to graph that on our screen. So go ahead and take a moment. I want you to graph A prime, B prime, and C prime, okay? And so you can see that here is where the image should be. I just translated it. It went to the left and down 1. Please go ahead, and I want you to perform the dilation. And you can see this dilation, only the x-coordinate is changing. It's being changed by multiplying by 3. So fill in the coordinates for A double prime, B double prime, and C double prime, and then graph the dilation, please. I would hope that this isn't taking you too long. It shouldn't be. Again, remember, once we are performing a sequence of transformations, we are looking at the previous point. So we had 1, 1. So we multiplied the 1 of the x by 3, and the y1 stayed the same. 1 times 3 is 3, 4 stayed the same, 2 times 3 is 6, and then the 1 stayed the same. And then I graphed A prime, B prime, C prime on our plane. The last thing that we're going to do is we need to find the rotation. And notice the coordinates stay the same, but the signs become the opposite signs. So again, please find the points and then graph it. Okay, so after performing our rotation of 180 degrees, because x, y stayed the same, just their signs changed, I see that 3, 1 became -3, -1, 3, 4 became -3, -4, and 6, 1 became -6, -1. And I have graphed A, B, and C triple prime right on the coordinate plane. So those were extremely easy transformations as long as you didn't make any mistakes. If you made any mistakes, then it's a little difficult to, you got to figure out where you made your mistake and kind of go back to that point, okay? Please keep in mind that all of this that I have on my paper, you should have on your paper as well. So all of these points, I found A, B, C, then all the prime, all the double primes, all the triple primes, they should be on your paper. You cannot expect to do this much work in your head and not forget what things are. So if this is not on your paper, I want you to stop and rewind and rewatch this, writing it down. Moving on. Example number 3. Triangle CAT has vertices C5, -2, A1, -5, and T6, -5. and it's rotated 90 degrees around the origin. The image is then translated. The final image of C has coordinates -4, 7. What is the translation vector? Ooh, hard question. I know a lot of you are just going to probably just let me talk the whole way and not try, but I want you to try. This is an example of a problem that would be on the EOC, a word problem that you'd have to figure things out. So first of all, I know that we are starting with some point x, y, and it says that it's rotated 90 degrees around the origin, and when it's rotated 90 degrees, x and y change places, and then the first coordinate, that y, is negative, and then it's translated, but we don't know what the translation is going to be. It's going to be something, but we're not sure what that something is going to be. However, I do know specifically some details about point C. So point C, what are the coordinates of point C? Well, the problem says they are 5, -2. Okay, well, can we rotate those points? 5, -2, the points 5, -2. And the reason specifically I'm looking on C, talking about C, is because the question talks about the final image of C. So I probably don't even need points A and T right now because it's only asking me about C. So C is 5, -2, and when we rotate it 90 degrees, the -2 and the 5 change places, okay? But then I have to apply this negative sign right here. Got to apply it. Well, I already have a negative sign, so when I apply a negative sign to a negative sign, the negative sign goes away. So this is just 2, 5. That's my rotation of 90 degrees. And then it says it's translated. It doesn't tell us how it's translated, but it says the final image is -4, 7. So I don't know how it got to -4, 7, but it got to -4, 7. It became -4, 7. So we just have to figure out how it became -4, 7. This is where some geometry comes into play. Not some geometry, I'm sorry. This is where some algebra comes into play. I'm at the number 2 right now, and I have to get to the number 4. So 2 plus something gives me -4, okay? And then my y-coordinate was 5. I added something to it, and I ended up at 7. 5 plus something is 7. So with our algebra, we know that I want to get x by itself. I want to figure out how 2 became -4. So I'm going to subtract 2 from both sides, which then gives me x on the left-hand side, -6. Okay? So x then moved to the negative, to the left, 6. Okay? Looking at 5 plus x, I want to get the x by itself, so subtract 5, x equals 2. So y went up 2. Okay, so think about it. I added 2. 2 minus 6 gives me -4. And then I had a 5 plus 2 gives me 7. So the question said, what is the translation vector? Well, here is our translation. Here's what happened, but we need to write it in vector form. So the final answer is what do you think? There you go. Again, my geometry scholars, this was not a hard problem at all. You can see I wrote down the rotations, I plugged in the numbers, and I did 2 simple geometry problems and ended up with the answer. I'm sorry, 2 simple algebra problems. 2 plus x equals -4. That's stuff that you've learned a long time ago. You just have to use your critical thinking skills to figure out how to solve the problem, because the actual solving of it was not overly difficult. Okay, we're going to move on to example 4. Use the definition of congruence to decide whether the 2 figures are congruent, and then explain your answer. So changing over here to the highlighter. There we go. By looking at those figures, what do you think? Well, the figures appear to be the same size and the same shape. And we can match C, D, E, F onto J, K, L, M by a reflection across the y-axis. And since this is a rigid motion, the two figures are congruent. So we can reflect it. We can see that F is 2 away from the y-axis and M is 2 points away from the y-axis. And D is 8 points away. Actually, I'm sorry, this coordinate grid's counting by 2. So D is 8 away from the y-axis and K is 8 away from the y-axis. And all these points are reflected. So yes, these two figures appear to be congruent. Looking at example B, what do you think about these? Again, the figures appear to be the same because you can map triangle ABC onto triangle XYZ by a 90-degree counterclockwise rotation. Okay, so if I take ABC and I counted their coordinates and I did a 90-degree counterclockwise rotation, it would land right there. And again, this is a rigid motion because the size is not changing, so it is congruent. And if you wanted to double check that, you definitely could. All you will need to do is find the points of ABC and then a 90-degree rotation is negative yx, and so just switch the coordinates around and change the sign of the first one and see if you ended up getting the coordinates of x, y, and z. And I guarantee you that you would. Okay. Lastly, I know this has been an intense lesson, but there's a lot of information, and I told you at the beginning, you definitely want to make sure that you are caught up because this is intense. Example 5, the figures shown are congruent. They're already telling us they are. Find a sequence of rigid motions that maps one figure onto the other and give coordinate notation for the transformations you use. Now, there are likely to be more than one right answer. But I'm just going to show you on each of these one way that I would solve it. So looking at example A, what do you think about the shapes? What do you think looks like happened? Well, when I'm looking at example A and I'm looking at triangle ABC and triangle PQR, to me the first thing I would think is it probably rotated. Okay? So I would say first of all, I'm going to move this down just a little bit right here. It definitely looks like maybe that it rotated because it moved 2 quadrants. And so I'm going to see if that is indeed the case. So since I think it rotated 2 quadrants, what kind of rotation would that be? Hopefully you said that would be a 180-degree rotation. So 180-degree rotation is negative x, comma, negative y. So I'm going to pick point A and try and see what happened with point A. So the coordinates of point A are negative 8, 2. And I told you guys earlier in class, making sure you're checking the coordinate grids because not all of them count by 1. As you can see, this one is counting by 2. So point A is at negative 8, and it's right here, and that's a 2, not a 1. And I'm going to compare it to point P. And I know to compare it to point P because when I'm looking at the triangle, A is the first point and P is the first point. So those are congruent points, okay? Or those are corresponding points, I should say, because they're in the same order in the name. So I'm going to compare it to point P. And point P is halfway between 8 and 10. So obviously that would be 9. So P is at 9, 2. Okay? So P is at 9, 2. And that's what I'm trying to compare it to, is to that point. So negative 8, negative 2. And when I apply this rotation, I change my signs. And I'm sorry, and A is at negative 8, negative 2. I should put that A there. A is at negative 8, negative 2. When I apply my rotation, 8 becomes positive and 2 becomes positive. Well, does that get me to point P to 9, 2? No, it doesn't, but it gets me really, really close. It gets me to right there. So I'm almost there. So what else needs to happen to this point, to 8, 2, to get me to 9, 2? How does that 8 become a 9? Well, hopefully you're using a little bit of logic and you said, well, you could translate it one more to the right. And you are correct. I can take the x, add 1. Do I have to do anything with the y? No, because it's already really good where it is. And so if I take that and x was 8 and I add 1, it becomes 9. And what do you know? My 2 stays the same. I've translated it, and now I've landed right on the point. So here's the coordinate notation for what we are looking for. The directions say give coordinate notation for the forms you use, and that's what we are doing. As we were solving the problem, I was having you write the coordinate notation, and that's what we did. We started with x, y. We did 180-degree rotations. This was 180 degrees. And then we translated it. Okay? This just takes logical thinking. Doesn't take hard work. Logical thinking and perseverance. It's not too hard for you. You can do it if you would like, if you want to do it. There are other ways. You could have also, instead of rotating it, we could have taken ABC and we could have reflected it across the x-axis and then across the y-axis and then translated it 1 over as well. So there's more than one right way, but I just said, you know what, it looks like a rotation to me, so let me try that and let me see how far away I am from that point, okay? We definitely want to make sure we check multiple points. So I'm going to take point C, okay, here's C, and C is at -2, and I'm going to apply the rotation. And where should I land up? What's my comparison point? Well, my comparison point is point R, because it's, again, in the same, it's the corresponding point to point C. So I need to be at point R, which is right here, and point R is at 3, 2. So let me see if that works out. So I'm going to apply the 180-degree rotation. So -2, -2, they stay in the same order, but the signs change. So since they were negative, they now become positive, and I'm almost there. And then I need to apply the translation. Well, 2 plus 1 is 3, and the y stays the same, 3, 2, and sure enough, I ended up at 3, 2. So I've checked another point, and it turns out. Okay? I know for a lot of you, this is probably more thinking outside of the box than you want to do, and I realize, again, this has been a long video, but I did warn you, this was an intense lesson. At this point, I want you to go ahead and pause the video, and if you need to write anything, write it down, because I'm about to erase this to do example B. Okay, so moving on, I'm going to figure out how JKLM became WXYZ. And again, I already know they're congruent, so how did they get there? And just by taking a glance at this, what would you say they did to JKLM to make it WXYZ? And probably a lot of you are thinking right now, well, it looks like they at least reflected it. And that's what I would say also. Definitely looks reflected or flipped. So that's what I'm going to start with first. And I am going to use all of this writing space, so ignore the fact that it's under A. I just want to use all this writing space. So we're starting with point X, Y. And I would say the first thing that it did was that it reflected across the x-axis. So looking in your notes, what do we do when it's a reflection across the x-axis? Well, x stays the same, y becomes negative. Okay, so I'm going to pick a point to work with, and I'm going to pick point J. And J, the coordinates of J are 6, 2. And what is it? What is J's corresponding point on the other image? Hopefully you said it was W, because J is first and W is first. And W is at 2, -4. So I need to figure out how to get point J to be the same coordinates as point W. Okay? So J, we're starting off with a 6, 2. And I'm going to apply this reflection. Again, there's other ways, but it looks, I can see right away in my mind, in that visual mapping, a little bit of ability I have, I can see that it reflected, okay? So I'm going to apply the reflection. So the 6 stays the same, and the y becomes negative, so it's 6, -2, okay? So now I'm going to draw this new point for you in blue. Now I am right here. okay? And I started here. Now I'm where the blue is, and I need to get to here, right? That's where I need to get. So how can I get that point, the blue point, how can I get it over to the green point? What kind of transformation would that be? Okay, I need to move it along the x-axis. I need to move it to the left. How many points? 2. And I need to move it down the y-axis. How many? 1. So there's my translation. And let's see if that works. So I'm at 6, negative 2, and 6, okay guys, I apologize. I forgot the fact that this coordinate grid is counting by 4s. I'm counting by 2s. So I'm at 6, I need to get to 2. So I actually need to move 4 over because this is 2, 4. And then y, I am at negative 2. I need to get down to negative 4. So I'm going to subtract 2. Okay, do you guys see that? This grid is actually counting by 2s, not by 1s. So my apologies. It's 2 squares, but it's actually 4. Okay, so again, I'm back at 6, negative 2. And I'm going to apply the translation. Well, 6 minus 4 is 2, and negative 2 minus negative 2 is negative 4. And let's see, is that I end up at W? And sure enough, here's point W, so I ended up on point W. So here, again, is the coordinate notation. I simply wrote the coordinate notation as we were working together along. I started at XY, I reflected it across the x-axis, and then I translated it. And we're going to check it with a point. Let's just pick another point. We'll pick L because it's in the middle. So L is at point 6, 6, and its corresponding point would then be Y, which is at point 2, negative 8. Okay, so let's see if we can apply these transformations and end up where L maps onto Y. So L starts off at 6, 6. We need to apply this reflection, and so it becomes now 6, negative 6. Okay, and then we're going to apply the translation. So 6 minus 4 is 2, and negative 6 minus 2 more is negative 8. And what do you know? We ended up mapped right on to Y. So again, here is the coordinate notation for it. This is our starting point. I'm going to put an SP for starting point. This was a reflection, and it was a reflection across x-axis, and then a translation. And this will take practice, and we will do some of these in class. But again, if you're comfortable with just rotating and reflecting, this will easily be a piece of cake for you, or so for some of you, I know it is because you've been working hard. And again, there are more than one right answer. We're just finding a way. So I'm not expecting you to be pros on this, but I am expecting that you have tried. Okay, guys, go ahead and please write a summary, something you learned about this lesson, and I will see you next.